Welcome back to part 5 of the Yamaha B-6 restoration. We've got a lot of work to do in this video. I want to get this amplifier on my load bank and the audio analyzer and hopefully run it up to full power. Keeping in mind, running it at full power, it's the most stress this amplifier has probably ever seen, and there's a lot of potential for things to go wrong while there's a lot of power and current running through this, which is not a good combination. So we need to make sure everything is perfect, all the ducks are in a row. So we're going to start with this power supply. We need to get this triac mounted on this metal plate. I don't know how much cooling it actually needs, but it needs some sort of cooling, obviously. So we'll get that remounted. We've got to make a pad for this to get it on there. And I've got to check this spacing as well, because I don't think it's meeting the metal surface properly and without pressing on this PCB. So we may have to remount the triac again. We'll go through that. I've decided I'm going to change all these transistors here just because this power supply is like, if something goes wrong with this, we can kiss everything goodbye in this amplifier. So I'm going to really err on the side of caution and change all the transistors here. Then we're going to attempt the power supply adjustment. I'll take you through that. It's been really hard to understand what the service manual is referring to in regards to this. I've got little test leads everywhere trying to figure out what I'm doing. Anyway, we'll get that done. Then we're going to move on to this, make sure all the calibrations are good on this, and then I think we should be ready to move it across to the load bank and see what happens when these voltage rails switch. Who knows? A little scared about that, but anyway, let's get started and get to work on this power supply. Right, so the power supply is all done other than maybe a little bit of a clean. I decided to move the trim pots to the back of the PCB so I can make some future adjustments if I need to once this is mounted. And the next issue I need to deal with, which I inherited from everyone who's worked on this amplifier before, this is the triac mounting plate that goes through there, and the threads are basically stripped out on it. It only had like metal tappers, these ones here, and there's just nothing left. So I've got to try and save this, and I've decided I'm going to go back to the Blue Demon aluminium welding rod, and we're going to try to make that work. So I did a proof of concept on some aluminium stock with an M3 nut, and it's actually bonded really well. I'm not sure what sort of material these nuts are made out of, if it's like a nickel or something, but it's adhered very well. I don't think there's going to be any issues there. It's really gone up onto the sides of it and it's holding on. It doesn't need a lot of strength anyway. I just need the nut to stay in place while I tighten it down. So we're going to attempt that. So anyway, this is going in the ultrasonic cleaner for quite a while to try and get rid of all the paint. I've ground down the threads on the back, so I've got a flat-ish surface. I've got the thermal pad / insulator ready to go. This is just a cardboard one. I'll cut out the final one shortly once we know this works. But that's the next thing we're going to deal with. So I'm going to go chuck this in the ultrasonic cleaner and then we'll try welding on it. Well, this is far from my finest work. This looks absolutely horrific, but it's durable. These are not going to come out again. And yeah, these welding rods are just really hard to work with. You either have too much heat or too little, and I was trying to scrape off the excess and I couldn't get it off, and that was a really big mistake. I shouldn't have touched it. Live and learn. I'll keep working on getting better with it. But it started to melt here, so I couldn't go back and reattempt this again because this whole thing would just collapse into a puddle if I tried to do it again. But it will work. I've chased the threads on the nuts with a tap and everything is perfect. Got a really strong mount here. Got the new thermal pad cut out, which is going to just sort of sit on here between the triac and the bracket. So we're going to try and get this back in. I don't know if the gap for the triac is correct. I followed the service manual, but I think it's a bit short, and it's probably why there's cracked in this area as well. So I may have to unsolder this again, which I'm not looking forward to get it seated properly, but let's just see what happens. So the power supply is all done. I'm done a bit of testing with it. Everything looks fine. And now we're going to tackle the main board. I'm going to go over this and do a few loose ends, get some things squared away. And then I'll take you through the calibration across the entire unit in sort of one section. There's not a huge amount to do here. There's just a lot of nitty gritty things that I'm not happy with. It does work fine. There's no issues that I can see so far. But the left side has had repairs done on it in the past, and the right side is stock from what I can tell. So these transistors are different to this side. They're completely different make of transistor, different model, and I don't like that. So we're going to match those together. These transistors here and over here are different as well, and also the temperature tracking compensation transistors up here, something is different about those as well. They've got a different package, and one is face up and one is face down. I don't like that. Now, only in extreme situations will I consider using different parts on each side. When I do amplifier restorations, I've gone to all this work. I want the same parts on both sides. I want each channel to perform the same as a mirror image, and I just want the unit to be consistent. You know, I don't want different parts on each side because I don't know what effect that's going to have on the sound. You know, the coefficient of how the amplifier tracks with temperature, with biasing, DC offset, things like that. So anyway, Wagner to the rescue. I managed to buy a ton of new old stock transistors, and these were not cheap. Because I bought spares as well, but this was over $100 of transistors just here. Yeah. So I've got extras of pretty much everything, so I can try to gain match the transistors across each side. I've got a decent chance of doing that with 10 total per transistor type. So we're going to go through that. I don't know exactly what I'm going to use yet. I may do some last minute changes, but we'll figure that out. Right, so a bit of voiceover work again. Going through changing out these temperature tracking transistors, I'm actually using the same part that was in there originally. I managed to find some new old stock. I didn't want to try using something new because of how important the characteristics are for these transistors in locations like this. So I'm going through and gain matching and sort of ranking up the transistors in this clip and trying to find ones that have a very similar gain, and I've selected 2 there. And you can see, I don't know what happened, someone's replaced one at some point, and you've got a long one and a short one. The gains are completely different, and here is the new ones that are perfectly matched and trending really nicely together. Thank you to Yamaha for not routing the PCB in a way so the transistors are around the same for each side. One is face up, one is face down. I hated that. So I did sort of a leg flip around so I could put them both face down on the same heatsink surface. So hopefully they will track better than they did before. But that is factory. That is not something that someone else has done with a different transistor package. Right, so going through and just matching up some transistor pairings again. I had a decent batch, so I could go through and find the best ones I could. The old ones were quite far apart. The new ones are very close together, as you can see here. These are the drivers for the output transistors on each side, so I wanted these to be, as close as possible. I guess it probably doesn't matter, but, you know, I had many to choose from, so I'll get them as good as I can. So the ones I'm putting in are actually what someone used on the repaired channel already, and whoever did the substitution and repairs on that seemed to do a really good job because they picked transistors that were a really good match for the originals. The originals weren't really possible to source, so these were the next best thing, and I was able to get new old stock for them, which was excellent. And here I am just repairing, cleaning up the traces a little bit. These transistors have been in and out a few times and the traces are looking a bit worse for wear. Just cleaning them up with the fiber bristle brush and making sure everything is perfect. Right, so I got all the transistor replacements done. Everything went well except for these 2 transistors on each side here. They're just a little difficult to substitute. Now, someone had already replaced the pair on this side. So this side is stock, this side has 2 different ones. And they seem to be working well, but I was trying to get a replacement that I've got to do both sides so everything's the same, and I didn't have much luck with that. So I'll show this graph comparing them all, and you can see the slow ramp on the older ones that are used on each side. So they've got 2 different types, but you can still see the similar ramp or the transition. And the newer ones, pretty much everything I've got has got this very sharp sort of knee in the curve. So I tried them, they don't work. Basically what happens is the bias jumps up to 15 millivolts as soon as you turn this thing on, and that's with the adjustment turned all the way down. So they're not going to work in there, in that spot. The 2 transistors that are on this side, I can get new old stock versions of those. And I think I'm just going to do that and just use those ones because they seem to be working on this side. But we're going to load test it and see if they actually do work all the way up to the rated power. And if they do, I'll just order more of them and I'll make sure both sides are matched better than what it is at the moment. So anyway, adjustments. Now, the adjustments on this amplifier are a bit of a weird thing. I know X-Ray Tony did a video on this saying that this thing is like a loaded gun and it just wants to run away. It hasn't been my experience with this. Mine's honestly been pretty stable, so I don't know if he's got a weird unit or if he's got other faults going on, but honestly, the adjustments have been pretty smooth for me overall. Now, the first thing we have to do is this power supply. There are two adjustments with these two trim pots here. We have to set the rail voltage, which is 76 volts, and we have to set the optocoupler working point, which is 60 millivolts. The service manual is not super clear on this, but I found some references to some Japanese sites and a German forum as well that actually showed some useful information. So there are two test points down here, and they are subtly labeled 1 and 2 with square pads. It doesn't actually specify that there are actual test points here, but there are. And we need to clamp onto there for the optocoupler working point, and for the rail voltage, we have to clamp on to these switching transistors, or just one of them, should I say, and a grounding point, so I'm just using the ground on the audio input section. So I've already set it to 76 volts for the supply rail, and the optocouplers tends to float around a little bit, but 60 millivolts, and it is pretty stable. And I also have my oscilloscope on the one of the power resistors, which is looking at the triac, and the pattern we're seeing here does seem to replicate what it says in the service manual. So everything is looking good here. I will mention that measuring this resistor, you either have to float your oscilloscope or you need to do a 2-probe measurement. So I'm going into each channel, and it is doing a math function between the two channels, because you cannot ground out this section unless you want a lot of fireworks, blow up your oscilloscope, blow up the amp, you know, a lot of things can go wrong. So you don't necessarily need to measure this if it is working fine anyway, but if you do want to measure it, tread very carefully and make sure you know what you're doing, and do not ground out the main power supply, because you'll have a very bad day. But yeah, this is pretty stable, and honestly, even when it was way out, it didn't try to run away or do anything crazy. The supply rail was quite high, and I just had to turn it down, and it didn't try to blow itself up or annihilate itself. So I think what happened with X-Ray Tony is something completely unrelated, or there were other faults in his unit. Right, so the bias and DC offset are the adjustments we do on the main board, and there's 4 adjustment points, those blue trim pots. There's one here, there, and there. 4 test points on the board, which I've completely replaced and glued down, so we've got proper solid test points now. These are for the bias, which are already clamped onto, and the DC offset I'm just measuring at the speaker terminals. So the bias is pretty good. It's 2.5 millivolts. It's running pretty stable, but it is very thermally sensitive, which is pretty typical. Very low bias, which makes sense considering there's no real cooling on this thing other than the enclosure, and it's supposed to be sort of power efficient. And it tends to idle around 23 watts. That seems to be its happy place also. So yeah, I ended up replacing the trimmers for the DC offset with multi-turns, because they are incredibly sensitive, and the multi-turns just make things a lot better. So there's Burns multi-turn trimmers in here. I used to be of the opinion that multi-turn trimmers everywhere, but I tend to use them a bit more carefully these days, because I've had a few situations where I've needed to make a quick adjustment or see where an adjustment is on a board, and you can't do that with multi-turns. If you've got like a 22-turn multi-turn trimmer, if you need to change that quickly, like back it off really fast, you sit there for a minute trying to unwind the thing, and you can end up damaging the board. Or if you need to quickly look where a trimmer's sitting in its position, you can't check that with multi-turns also. So I tend to use them a bit more thoughtfully these days. But in this situation on DC offset, I've got no problems using multi-turns, and the DC offset's pretty good. It does drift around a little bit, and yeah, one side is original, one side is the one I've rebuilt already, but they seem to be acting pretty similar to each other, so we'll keep an eye on those. Keeping in mind, this is just sitting on an open bench. It's got air blowing over it, and if I just blow on it, you can affect the DC offset pretty significantly. So yeah, they're very thermally sensitive, and that's why I tend to do my measurements once it's fully assembled and the final adjustments. But it's good enough at the moment for us to move this over to the test bench, and we're going to load it up and see what happens. Hopefully we can run this thing up to full power. Sorry, a couple of last minute things I forgot to mention. I actually ended up putting the stock protection relay back in. The Omron relay was actually too tall, so that was not going to work out. It was just hitting the bottom of the plate ever so slightly, and it was just going to be too hard to make this board work with the relay pushing up against that plate. So I've decided to go with the stock one. I actually took it apart and I serviced it, cleaned all the contacts, ended up replacing the top cover because I had a spare. The cover that was on here was sort of heat stressed, and the cleaning process made it very brittle also. Epoxied the quenching magnets back on, which Yamaha like to fit on all their relays. And I actually think it does work because the contacts were really, really good in this relay, which was quite a surprise. So yeah, stock relay. Wish I could have used the Omron one, but it's just not going to work. It's just too tall. I ended up doing the other pre-drives, so they're both matched now. They've both been completely rebuilt. So that's all good. And I went back and got another substitute for these two transistors, and I gain matched them to both sides. So I got new old stock for both of them. So everything is the same across both sides now, which I'm really happy about. Right, so I've got everything good to go. It is quite a hot day today, so the measurements are going to be a little bit all over the shop with the bias, but we're not concerned about that. We just want to see its load performance. This looks like an absolute mess, but trust me, there is some method to the madness here. Got the power supply here, got the main board here, and it's supported on some wood blocks and mounted to a large aluminium block with the output transistors to take all the heat while we do some load testing. Got some fans on each side and one on the power supply. Probably not needed, but I just want to play it safe because it's going to be under a pretty heavy load. Audio analyzer's up and running. It's just been warming up for a while. Got the oscilloscope here, which is going to be watching the waveform. These two multimeters are just watching the bias. These two multimeters are watching the collector voltage on the NPN and PNP output transistors, and we have the mains power here so we can keep an eye on what's actually happening power consumption wise. So we're going to take this slow and steady. We're going to bring it up to a light load, let's just say 1 watt. Then we're going to do some cycles going from 20 hertz to 20 kilohertz, and then we'll start ramping up the power slowly, and we will see what happens. And just so everyone's aware, we'll be seeing the frequency here, and this will be the distortion measurement here. This Shibasoku bottoms out about 0.003% distortion, so we're not going to see any lower than that, but it should give us a rough idea of what's going on. I'm using my DAC just so I can control the volume really easily. I can't control it quickly on the audio analyzer if I need to back something off really fast. So this is just for convenience so I can adjust it really fast. So I'm going to get the camera set up in an angle where you can see everything and see what happens. Right, so I think this is the best angle I can get you. You should be able to see everything. This meter's going to keep going to sleep. I'll try to keep waking it up, but it's only got the bias on it anyway. The main ones I'm concerned about are the collector voltages as the rails switch from the 36 volt rail up to the 76 volt rail. So I want to make sure that that does what it's supposed to do and everything's tracking pretty evenly. So I'm going to bring in the test tone. So this is a 1 kilohertz tone. And audio analyzer's picking that up, so we're good there. I'm going to bring this up. All right, got a good signal. Good. There we go. That's about 1 watt per channel. So 0.01 versus 0.01. So the channels are tracking pretty evenly. Not too much difference there. I'm just going to let it sit at 1 watt for a few minutes and then we'll keep ramping it up. So I'm now going to bring it up to, let's just say 5 watts. And then we're going to do some cycles from 20 hertz to 20 kilohertz. I think that's probably going to be a good little exercise. I'll rescale the oscilloscope. Everything looking good so far. I'm just checking the distortion and the channels are tracking really well, 0.006, and that's already at 5 watts, which is really impressive. So let's take it up to 50 watts, so that's 20 volts RMS per channel. Won't do this for too long, but we've got a long way to go still. Wowzers, 450 watts already. Collectors have already gone up to 72 volts. So you can see over here the collector voltage, and it seems to be, from what I saw, around 15 volts. You can see it's sagging down to 31. And then it's going to start ramping. There we go. It's not tracking very evenly though, which is interesting, but it seems fine. It's not affecting the distortion. 0.004, 0.003. Wow, distortion's really impressive. All right, back that off for a minute, let it cool down. Aluminium plate is definitely starting to warm up, so let's keep this moving. We're going to go to 100 watts now. That's 28.3 volts RMS. We'll do a short burst on this one and not hold it there for very long because it's a pretty heavy load for this little amplifier. Well, not little, but lightweight. $620 watts. Woof. Insane. All right, backing that off again. Took that fine. All right. 200 watts RMS, we're going for it. That's the rating of this amplifier, and we'll see if it actually holds it there. We'll probably hold it there for like 5 seconds. I don't want to stress this too much, so taking it up. Ooh, she's humming. 003, 940 watts. Wowzers. All right, still didn't clip. That's a lot of power. That was about 210 watts. Alrighty, I wonder where it's going to clip. Alright, let's stop screwing around, see what point this amplifier just starts clipping at or it gets too much distortion. This will be a very short sprint. I'm not going to hold it here for very long. And yeah, go for gold. That's it. Whew, that's a little scary. I can hear the transformer humming. Looks like around 220 watts per channel, roughly. Seems to be where it starts to get too much distortion. It gets more distortion before the clipping point, which is interesting. Well, I think we're done here. I mean, it did its rated power at 0.003% distortion, probably even a bit lower. My analyzer bottoms out around there. I've been running it on a solid 20 watt load and just holding it there for quite a while, and it's doing 0.004 on both channels, so the channels are tracking nice and evenly. The voltage or the amplitude is balanced across the channels, so we're looking good there. Voltages are looking good. Power draw is looking good. Needs a few little final calibrations once the temperature settles down. It's quite hot in Australia at the moment. And yeah, we're ready to put this thing back in its enclosure and close this project out. Well, this amplifier finally bit me in the ass big time, and I've got a bit of work to do in regards to getting this sorted. Long story short, I was moving some cables around and one of the RCA inputs on this board fell out and the amplifier was idling at the time, and it turns out this is one of those amplifiers where it's very, very trigger happy with its input signals, and basically that RCA connector falling out while it was idling must have sent it into an oscillation or something, and it blew out the right channel basically instantly. 2 out of 4 outputs survived. The other 2 are completely shorted, and like it was insane. The RCA came out, flashed a blue flash from the fuse. Fuse is gone as well, and it was dead. Like split second. It was unbelievable. I don't know how robust these outputs are, or if it just went into a crazy oscillation, but yeah, this is a problem because you cannot really get these transistors anymore, not in this package type anyway. There are some sources that have them, but they are stupidly expensive, and I am not going to pay the money that is required to do one side of this. So I am going to put in some newer transistors in a different package, and we're going to adapt all that. Decided I'm going to end this video here because this is a bit of a setback. I will not be defeated with this freaking amplifier. It is going to work. This is a little setback. We're going to get some new transistors. We're going to figure out how to mount them. I'm currently playing around with some different package types. This is one of the transistors I've ordered, and just comparing if we can make it fit on the plate. And it does look like we can make that happen. It's going to be tight, but we have a few different potential options there to make this happen. So yeah, not great, but the Yamaha B-6 reputation lives on, I guess. But this is not the end. It will work in the next video, no matter what it takes. So yeah, thank you for watching this video. We'll be back with the final iteration very soon.